Here. I am Jose and I'll be presenting my major project part 2, question 5. So let's hit it. My question is, in performing an analysis of variance for a single factor experiment, a fundamental assumption which is made is that the factor A means are equal, B means are unequal, C variances are equal, and D variances are unequal. So for A means are equal. Um, You might wonder what's wrong with this answer. Well, actually, this is the reason why we are testing the ANOVA. It's to check whether the means are equal or not. We are now making an assumption. That's why it's the null hypothesis. So we assume that the means might be equal, but the ANOVA helps us to find out if they are really not like equal overall. For point B, means are unequal. So this is the opposite of the first choice we had. So it's the opposite of the null hypothesis. It's actually the alternative hypothesis. And it's what we believe might be true if we find a significant difference. But again, we're not assuming that, what's going to happen. That's why we're testing for. So this might look different, but the ANOVA checks for the difference statistically to see if there's any significance or if it's just random. C, variances are equal. Well, this one's actually correct. I think this is the answer. And that's why, because I feel that the ANOVA assumes that the different groups or populations might have equal variances. I think that the terminology used was homogeneity of variance of assumption. And it basically ensures that the comparison of the means is fair and valid. So we can see in the example A, B, and C that they are both within the same field. So we have 10, 9, and 11. So they are close. Therefore, we can actually use the ANOVA. And for D, variances are unequal. Well, if the variances are unequal, maybe the results with the ANOVA might not be the best. And it could basically lead to incorrect conclusions. And if this is the case, we might need to use another test to find it, but we're not going to go into detail. Um, we can see that the A, B, and C example, we have a large variance. So for A, we have 5 hours, for B, we have 30, and then to C, it's basically 50. It's way over, so it's incorrect. Thanks again for your time.